Hi guys, I'm Matt from the Traveling Together Journal, and this is my new Overland camping setup. I built this custom hard-sided pop-up camper on my four-wheel drive Toyota T100, complete with a solar system, a water system, an awning, lots of storage, a composting toilet, and a queen-size bed.
This plan started off as fireside chat, then became sketches that kept getting reworked, and then eventually drawn in a 3D program called Tinkercad. The end goal is a vehicle that performs on and off-road at least as well as our last build, but will be much easier and more comfortable to use in hot, cold, windy, rainy, or populated areas, thanks to the insulation, accessible storage, and indoor kitchen and toilet, all things that we lacked in our last build. We've removed the stock truck bed and rear bumper so that we can build a camper from the frame up.
So we used our cheap Harbor Freight chop saw and cut all the steel to the lengths that we need it to be. And we're going to start with just getting some tacks to hold our pieces together, and then we'll move the tacked together frame around in order to get the easiest possible weld angles on each piece. And we'll be welding all the way around each seam. Alright, we got the center ladder all welded up. Now I need to make the mounts. I got all my pieces of 3/16 inch by 2 inch flat bar cut to make the forward mount, and I'm going to go over to the truck and clamp everything in place and tack it together, then pull it back off the truck to fully weld the inside of everything. So we got our pieces cut for the center mounts, and just like the front mounts, we are now going to tack them while they are in place on the truck. And then we'll remove them, fully weld them on the bench, and then bring them back over here to put in place again. Aft mounts welded up and ready to be put in place, tacked onto the subframe. Now we're putting together the sections that are going to go on the outside of the frame rail and sort of frame out where the wheel well will be.
I used some creative clamping and regularly checked the level to make sure I was getting these sections put on straight.
Alright, use the angle grinder to round off the corners on the back of the subframe here. And then I've got these 1 inch flat bar pieces that I'll weld into place and bend around so that the corners on the subframe will match the 1 inch radius that I plan on putting on the camper. Alright, so we got all the work done that we're going to get done with the subframe bolted in place. So we're going to be taking it off the truck and maneuvering it around so that I can get some more welds on there. Well, I finished grinding down all the welds on top of the subframe, so I'll have a nice smooth surface to adhere the camper to. So we've got our Pettit Rust Lock 6980. We're just going to be putting that on with a 2 inch chip brush.
And there you have it. Our steel subframe is primed and ready to go. Now we just need to build a camper.
The first thing we're going to be working on though is the mounts. So I've welded these tabs in place on the subframe. The sheet of plywood will go over the top of that. And then we're going to be using these T-nuts as fasteners. They're going to be inside of the floor. So they'll be sticking down through the plywood. And I'm just always a little bit worried about the wood fatiguing over time with the stress. So we've got 10 of these throughout the subframe. And then I'm also going to be using these large fender washers to help displace the load a little bit more. With the T-nut mounts all drilled in and dry fit, we're now going to change gears a little bit and work on the internal framing.
Each piece of the frame is attached to the plywood with exterior grade wood glue and countersunk deck screws. The frame members are attached to each other with wood glue and pocket screws. So it was basically glue, screw, and repeat, and the frame came together really nicely. Now I'm ready to turn my attention back to the mounts. With the hardware removed, I saturated the wood in epoxy resin and laid a piece of 6-ounce fiberglass around the hole. Then the hardware was installed with the screws, and the bolt is tightened into the T-nut from underneath to compress the hardware into the wood. Then came another coat of epoxy and fiberglass to seal everything up. This was repeated 10 times, one mount at a time, to ensure that all the mounts stayed aligned with the tabs on the subframe. With that done, I was ready for the top sheet of plywood. This is the same 15/32 inch 5-ply underlayment that I used for the bottom sheet. It is attached using lots of wood glue and clamped in place while I fastened it to the frame with countersunk deck screws. The center part of the floor is now ready to be filled with foam. If we look back at the internal frame, you can see how it separates the space between the plywood skins into 8 separate voids. I tilted the floor up on its side and filled the 4 passenger side voids, then flipped it over and filled the 4 driver side voids. The pour foam is a 2-part polyurethane foam. I measured out each part in separate measuring cups, then poured them into a disposable cup for mixing. The pour foam is still a new material for me to be working with, and dividing the space I was filling into 8 separate sections made me feel a lot more confident that I was completely filling each void. And now we are ready to skin the outboard sections of the floor using the same 15/32 inch plywood that I used for the center portion. To get a stronger joint between the center and outboard sections, I used a router to create a 2-inch wide lap joint in the plywood, before attaching it with wood glue and countersunk deck screws. With the last of the plywood attached and the floor back up on its side, I finished filling each of the voids with foam. After trimming the excess foam and getting the floor bolted back onto the subframe, I used a flush trim bit on the router to trim the floor down to the exact size and shape of the subframe. Now it's time to prep the floor for fiberglass by sanding it down nice and smooth and filling in any holes or cracks with epoxy, and rounding off the edges with a 1/8 inch router bit so that the fiberglass cloth can wrap around the edges. Epoxy and milled glass powder is mixed to create a paste that I use to coat any exposed foam. This was later sanded down to create a smooth, hard surface to glass over. I pre-measured and cut all of my fiberglass, set it aside, and coated the top of the floor and the edges in epoxy resin. Then comes the fiberglass cloth and more resin. I used the same process of resin, fiberglass, and more resin on the outboard sections, along with a little extra effort to get the corners to cooperate, and I was pretty happy with the results. After the resin cured, I sanded down the edges and flipped the floor over to glass the bottom side. It was the same process as the top, but with the added difficulty of working around the mounts. I inserted the mounting bolts covered in masking tape to prevent getting resin into the mounts, then carefully filled any gap around each mount before moving on to the fiberglass. At this point, the floor is completely coated with epoxy resin and 6-ounce fiberglass, with 2 coats on the edges. After sanding down the bottom of the floor with 80 grit sandpaper to rough it up a little bit, it is ready to be attached to the subframe. To prepare the subframe, I scrubbed it down with soap and water and roughed it up a little with the Scotch-Brite pad and wiped it down again. To adhere the floor to the subframe, I used 4 tubes of Sikaflex 252. With the floor in place, I tightened down the mounting bolts until the Sikaflex was pressed out of the edges of the subframe, and used clamps to compress the floor on the outboard edges. Now it's time to build some walls. The external walls consist of 5mm plywood and a 1x2 Douglas fir frame. I used pocket screws and exterior grade wood glue to join the pieces of the frame, and more wood glue to attach the frame to the plywood.
When we look back at the frame, you can see that this wall will have 3 voids to fill. I used a bunch of scrap material to support the thin plywood so that it wouldn't bow out while the foam expanded. And then, with the wall in a vertical position, I mixed and poured the foam to fill the voids. With all the voids filled, I trimmed off the excess foam and sanded it down flush. Then used a router with a 1-inch radius bit to round off the corners that will be the front edges of the camper wall. Next came the fiberglass. I used 6-ounce cloth and epoxy resin to cover both sides of the panel. Once the epoxy cured, I drilled out pockets in each of the 4 vertical frame members so that I could screw the wall to the floor once I got it in place. With the subframe floor assembly pulled out away from the truck cab for better access, and lots of scrap material staged to help me keep the wall vertical, I used an epoxy paste and 4 pocket screws to attach the wall to the floor. Once the epoxy paste cured, I could remove the clamps and glass the seam. I started with a chopped glass epoxy mix to fill the joint. This will add strength and create a radius that the fiberglass cloth can easily conform to, so I'm not trying to shove the cloth into a 90-degree corner. I used 2 layers of 6-ounce cloth, the first being narrower than the second. This lets me cover the edges of the first layer, giving me a tapered thickness and fewer exposed edges to sand. The outside seam also gets 2 layers of 6-ounce cloth, and we've officially attached our first wall. The rear walls were built and attached using the same process. I used 2 separate panels for the rear so that a gap could be left for the door. The passenger side wall was also built using the same process. It had the added difficulty of accommodating the wheel well, but the benefit of having the rear wall to hold it vertical while I did the seam work. The seam between the passenger side wall and the rear wall also got the chopped glass paste, followed by 2 layers of 6-ounce cloth inside and out. Now we're ready to move on to the internal walls. These are constructed of a single layer of 5mm plywood and minimal amounts of 1x2 framing, with 6-ounce fiberglass and epoxy on both sides. They are attached to the structure with pocket screws, and all seams got the same treatment of chopped strand paste and 2 layers of 6-ounce cloth on both sides of every seam. It was a lot of seam work, but it is what will seal all the wood and hopefully create a strong, lasting camper.
Taking a look at the build plan, this is where we are currently at. All of the panels shown in pink are insulated, and the light green is non-insulated inner walls. The next thing we need to do is build this dark green panel. This will be the countertops and the bottom of the cabover. I'm building it out of 3/8 inch plywood. Its overall length and width are 128 inches by 75 inches, so I had to cut it out in 3 different sections and join them together. To make the joints, I routed 3/16 of an inch off of each of the joining edges to make a 2-inch wide lap joint, which I glued and clamped together, starting with the section that will be our countertops. Then I glued and screwed on the framing for the cabover, and then the forward panel for the cabover, which angles in at about 9 degrees on each side, tapering the width from 75 inches at the back of the cab down to 60 inches at the front of the cab. Once the glue cured, I coated the bottom in 6-ounce fiberglass and epoxy resin, then struggled to get my awkward creation onto the camper. With a couple of clamps keeping things aligned, I tilted the plywood panel up so that I could coat the top edge of the walls in glue before screwing the panel down with countersunk deck screws. Then I mixed up some epoxy, chopped fiberglass, and fumed silica to fill in all the joints, then finished each one with a layer of 6-ounce cloth. Now we're ready to start on the pop-up walls. I started with the 2 big panels on either side since they didn't have any windows, so they seemed the easiest. They are constructed using the same process I used for all of the other insulated walls. Each panel is attached to the camper with wood glue and countersunk deck screws. Next, I built the rear inner pop-up wall. I needed to recess the window frame in the wall so the aluminum trim on the window won't get in the way when the pop-up is going up and down. So I routed out lap joints in some 1x2s, and these became part of the frame for the insulated sections on either side of the window. The edges of the 5mm plywood were sanded down, and the corners of the wall were given a 1-inch radius with the router so that I could glass over them easily. The panel was put in place with wood glue and countersunk deck screws. Then all of the joints were done with chopped strand epoxy mix and a layer of 6-ounce cloth. And the countertops were also given a layer of 6-ounce cloth and epoxy at this point. Now for the Cabover walls. I needed to make 2 more walls with windows in them. I followed the same process I used for the rear wall to create a recessed window frame with an insulated section of wall on each side. But instead of routering off the corners, I used a circular saw to cut an angle on both edges to accommodate the tapered shape of the Cabover. Each of these sections was glued, screwed, and then glassed in place before moving on to the front wall. No windows in this one, just a simple panel with Douglas fir frame, plywood skins, and foam core. But I did need to cut the edges to meet the angle of the Cabover walls before gluing, screwing, and glassing it in place. With the inner pop-up walls done, I was ready to insulate the Cabover floor. The poor foam I've been using wouldn't work very well for this wide, shallow space between the Cabover frame, so it was fortunate for me we finally got some XPS products back in stock here in California. Unfortunately, it was only available in a 2-inch thickness. I found a basic handsaw cut through it pretty well, so I decided to use that to cut the foam down to the thickness I needed, using the Cabover frame as a guide. It took some effort, but produced acceptable results. I roughed up the factory finish on the other side of each panel with 80 grit sandpaper in hopes of getting a better adhesion. Then I coated the wood and the foam in epoxy and put them in place with weight on top to make a better bond. Next came a sheet of 5mm plywood. I coated the foam and frame in epoxy thickened with fumed silica to make it about the consistency of mayonnaise. And I painted the bottom of the plywood with unthickened epoxy before putting it in place and applying weight to it. I was satisfied with the result, and after a bit of sanding, I filled the seams with chopped strand and epoxy paste and applied a layer of 6-ounce cloth and epoxy. Finally, I added these little sections of 5mm plywood. They are glassed on both sides and glued, screwed, and glassed in place. They will keep the mattress from sliding off the Cabover, provide some separation between our bed and cooking surface, and act as a gusset for the pop-up wall. That completes the Cabover, and thus the entire permanent structure of the camper. Looking at my drawing, this is where we are at now. And the next step is to build the pop-up walls. The light pink areas are insulated wall panels, and the red is window frame. The insulated wall panels for the pop-up are built using the same process I used for all of the other insulated walls I've built so far. The corners of the rear wall were rounded off with a 1-inch radius router bit to match the corners of the lower wall sections. And the pop-up walls going over the Cabover were cut along the front and rear edges to accommodate the 9-degree angle of the Cabover. To build the panels for the windows, I started by cutting a piece of 5mm plywood to size and cutting out the hole for the window. The windows going in these panels are from an old camper shell, so they are designed to mount in a thin wall like this, making this part pretty simple. But I still needed to add some framing to the panel for rigidity and to mount it to the other parts of the camper. I ripped down a Douglas fir 1x2 with a 45-degree angle to fit into the limited space around the window frame and make it easier to glass. These were glued and screwed in place, and some regular 1x2 was used to finish framing the forward insulated sections of each panel, and the forward edges were cut to match the Cabover sections. Then I clamped each section in place and joined them with wood glue and screws. Because the front panel doesn't meet the other panels at a 90-degree angle, I couldn't just round off the corner with a router bit. so it was just roughed out with an angle grinder and flapper disc before assembly. After assembly, I used a palm sander and sanding block to smooth out the final curve. All the screw holes were filled with an epoxy fumed silica paste, and each seam was coated with epoxy and 6-ounce fiberglass. Now for the roof. I built this in 3 sections, each one with a Douglas fir frame, 5mm plywood skins, and filled with polyurethane pour foam. Then each section was put in place and attached with wood glue and pocket screws. Once that dried, I rounded off the top edge with a 1-inch radius router bit. Then I glassed the roof and over the seams onto the pop-up walls with epoxy resin and 6-ounce fiberglass cloth. To gain access to all of the inner seams between the walls and ceiling, I removed the pop-up from the camper. I used a mix of epoxy, chopped fiberglass, and fumed silica to give a radius to the inner seam between the ceiling and walls, and then I glassed the ceiling and all of the joints. And finally, I glassed the bottom edge, which is now the top edge since it's flipped over, before shuffling it back up onto the camper. To guide the pop-up up and down, I planned on using 5 drawer slides mounted between the inner and outer walls. The drawer slides aren't quite wide enough to fill the 5/8-inch gap between the walls, so each one was mounted with a spacer in the form of a 1/16-inch thick aluminum flat bar, and attached with Loctite construction adhesive and number 10 pancake head screws. To help me lift the pop-up, I installed 4 gas struts, 2 mounted as far forward as possible without interfering with the queen-size mattress, and 2 at the far rear of the camper. The forward ones are rated at 80 pounds of lift, and the rear ones are 60. I also put a couple of handles on the ceiling that make it easier to control the lifting and lowering of the pop-up, and some draw latches to hold the pop-up in place when it's down. To create a seal between the pop-up and the camper, I added a piece of 1.5-inch wide, 1/16-inch thick aluminum flat bar to the bottom edge of the pop-up, using Loctite construction adhesive and number 6 flathead screws countersunk into the aluminum. Once that was completely cured, I applied a D-shaped foam rubber seal with an adhesive backing to the top inner part of the aluminum flat bar. Next came a cap of 1.5-inch wide, 1/16-inch thick aluminum flat bar on top of the inner camper wall. To install this, I used VHB tape and countersunk number 6 flathead screws. I didn't use the construction adhesive here like I did on the pop-up aluminum edging because it required a fair bit of cleanup once the excessive adhesive was compressed out, and I wouldn't have access to the lower outer edge of this aluminum piece. The VHB tape is a bit pricier than the caulking, but clean and easy to use. I can't really film the seal in action, so here is an attempt at illustrating the design. There is a 5/8-inch gap between the camper wall and the pop-up wall. The aluminum flat bar sticks out a 1/2 inch from each wall, so the 2 pieces of aluminum overlap each other without making contact with the opposing wall. And when the pop-up is fully extended, the foam rubber seal is compressed between the 2 pieces of aluminum. Now we need to build the doors. We need one for the storage space on the passenger side that I'm calling the utility hatch. Then we need an entry door on the rear. And finally the big storage area on the driver's side that I'm calling the surfboard hatch. We are using the same process to build the doors that we used to build the insulated panels in the camper. I started by cutting some 5mm plywood into the shape of the utility hatch door. Then used exterior grade wood glue and pocket screws to build and attach a frame of 1x2 and 1x3 Douglas fir. I used the 1x3s running from the hinge edge to each of the latches to add some extra strength in key spots, and so that I would have a large enough area with wood core to mount the latches. With the top sheet of plywood glued to the frame, I filled the voids with polyurethane pour foam. Then cleaned up the excess pour foam and glued in the last piece of frame and the final strip of 5mm plywood. Then ran a router with a flush trim bit around the edges so that my door panel has a nice smooth wood edge all the way around. Next, I cut out the holes for the latches. I'm using 2 compression latches to hold the door closed, but the latches were designed to mount on thin siding used in commercial RV construction, so I made my own mounting hardware with some scrap aluminum. Now it's time to glass the door. It received a layer of 6-ounce fiberglass and epoxy resin on all exposed surfaces. To mount the utility door, I used an aluminum piano hinge cut to length and attached with Loctite construction adhesive and No. 6 flathead screws. Then I installed some pieces of 1/2-inch aluminum angle. These are installed with construction adhesive and No. 6 panhead screws, and will provide the compression latches with the needed purchase to pull against and compress the seal. Moving on to the entry door, the build process was very similar, except that I'm using a common RV entry door latch, so instead of simply using a 1x3 to mount the latch in, I used a few 1x2s to create the latch mounting area, and added this plywood spacer to the inside of the door, since the latch was designed to be mounted in a thicker door. Then came the epoxy resin and fiberglass cloth to all exposed surfaces. Next, I cut some pieces of aluminum T-section and drilled some mounting holes with a countersink bit, and mounted them around the edges of the entry door with construction adhesive and No. 6 flathead screws. I set the entry door aside at this point and moved on to the surf hatch door. Obviously this door is much larger, but it is built with the same process as a utility door. 5mm plywood cut to shape, and a frame of 1x2 and 1x3 Douglas fir, joined with wood glue and pocket screws. Then filled with pour foam before receiving the last bits of framing and a strip of plywood to even everything out. I decided to use an aluminum hurricane hinge to mount this door across the top edge. I cut it to a length 1/4 inch longer than the door and notched it on each end to fit with a slight overhang at the front and rear, to avoid water running into the storage space when the door is open. Then I attached the top side of the hinge to the camper with construction adhesive and No. 8 panhead screws, and dry fit the bottom side of the hinge to the door so that I could test fit the door and make any adjustments needed. A little sanding around the corners, and it was ready for me to cut out the holes for the latches and coat it in fiberglass and resin, before permanently remounting the hinge to the door with construction adhesive and No. 8 pancake head screws. Next, just like in the utility hatch, I installed pieces of 1/2-inch aluminum angle around the inside of the storage area with No. 6 panhead screws and adhesive. I slid the door back on, and everything seemed to test fit nicely at this point. I decided this would be a good time to paint the camper before I added any more hardware to work around. I started by mixing a fairing compound of epoxy and glass bubbles. The glass bubbles thicken the epoxy into a paste and make it easier to sand once it's cured. I applied it to all the exterior surfaces of the camper using a squeegee, trying to smooth out the worst of the imperfections. Then came 2 coats of primer and 2 coats of paint. I knew I wasn't going to put in the effort to make a super nice finish when I plan on thrashing this thing through the bushes anyway, so I just went with some exterior house paint instead of something nicer and pricier. The main point of the paint is really just to protect the epoxy resin from UV damage anyway. The bottom of the camper and the floor inside each of the storage hatches got 2 layers of Herculiner bed liner and an extra 2 coats inside the wheel wells. And I added this brown stripe just to break up the tan a bit. Now back to the doors. I wanted to keep the wood finish on the inside of the camper, so the inside of the entry door got 2 coats of spar urethane with UV inhibitors. It won't protect as well as paint, but will hopefully hold up well in the interior of the camper. The entry door is mounted on an aluminum piano hinge attached with Sikaflex 221 and No. 6 flathead screws. The final piece of the entry door puzzle was a striker plate for the latch bolt to close against. I built this out of some scrap 16th-inch aluminum flat bar and glassed it in place. The surfboard hatch door needs to be supported so it stays up when it's open. To do this, I mounted 2 gas struts. I started by dry fitting the ball stud brackets with No. 6 panhead screws. With the struts mounted in this fashion, I tested the door. It opened and closed smoothly without being too much to close or causing the door to spring open when you open the latches. So, with my mounting location finalized, I remounted the ball stud brackets with Sikaflex 221 and number 8 panhead screws. The compression latches were installed in the surf hatch and utility hatch doors, and an EPDM foam rubber seal with self-adhesive backing was applied to the aluminum trim to create a watertight seal. Now we're ready for the rear bumper. The bumper is made of 1.5 by 6 inch C-channel. I used an angle grinder with a cutting wheel to notch out where the mounts will go, then welded the mounts onto the C-channel, going all the way around the seam. Then I notched out the ends of the C-channel. I originally cut the C-channel 2 inches longer than I wanted the bumper to end up being, so that I could bend the center section of the C-channel around these notched curves on either end. Once I was satisfied with the shape of the notches, I used a large C-clamp to bend the protruding sections of the C-channel and hold it in place while I welded it to the curved notches. To get the final bends, I used a pipe wrench to apply a little leverage and finished welding the inside seams. Then I added a weld to the outside of each of the seams and smoothed it out with an angle grinder. Next, I added some holes to mount the tail lights. These aren't the best looking lights, but they were cheap and easier to mount than the sleek recessed tail lights. Next came a big hole right down the center. This is so that I can access the stock underbed spare tire carrier, where I plan to continue stowing my spare tire. At this point, I used a flapper wheel on the angle grinder to knock off the rust and smooth it out with a palm sander, before applying a coat of Rust-Oleum rusty metal primer and a top coat of Rust-Oleum stop rust enamel. The bumper fit nicely onto the stock mounting points on the truck frame, and the access to the spare tire carrier lined up as planned. Our leisure or house battery is a 200 amp-hour lithium iron phosphate battery from Lead Time. It will be charged by the vehicle alternator and a 400-watt solar array from Schaller. To accomplish this dual charging design, we will be using a Renogy DC to DC battery charger with MPPT charge controller. This unit will take power from the solar array or the alternator, or both, to provide the house battery with the best possible charge. To use the power stored in the battery, we'll run cable through a fuse block and then out to the various loads, including fans, lights, a fridge, and a water pump. With this basic plan in mind, I got to work mounting the house battery. I screwed 4 footman's loops into the floor and glassed over the mounting screws with chopped fiberglass and epoxy resin. I decided to mount the battery on the floor against the forward wall of the camper to keep the weight of the battery low and forward, and also because it will result in the shortest possible cable runs to minimize voltage drop. I'll need to run wires from this area up to the solar array on the roof, so I drilled a hole through my bed. I removed the top layer of plywood and some of the foam core from this small section of the bed platform so that I could glass in a piece of PVC conduit. Then I cut a hole through the roof with a hole saw. I attached the panels to the roof with Sikaflex 252. Flexible panels generally aren't as durable as rigid ones, but they have the advantage of being much thinner and lighter. This 400-watt array from Schaller weighs 30 pounds less than my previous 300-watt rigid solar array. Next, I installed a plastic through-hole fitting in the hole that I had previously cut in the roof and sealed it with Sikaflex 252. Once the caulking cured, I cut off the excess through-hole fitting, ran the wires, and mounted a cable gland housing over the through-hole. Next, I wired the panels together using the included cable and MC4 connectors, along with the branch connectors, to wire the panels in parallel. I mounted the DC to DC charger right next to the house battery, and continued working out how to run the other cables. I cut a hole through the floor and installed another through-hole fitting, and crimped eye terminals onto some 6-gauge cable. That runs from the starter battery, under the truck, and up through the through-hole fitting into the DC to DC charger in the camper. I used a bus bar to connect the common ground circuits, and installed a fuse block that will feed power out to all of my loads. Now that I had my layout figured out, I pulled everything apart and remounted it with Sikaflex 221 on all of the hardware that penetrates the walls to seal out any moisture. Next, I need to get the power out to where I want to use it, starting with the ceiling. I installed a plastic track to run the cables through. Then I ran the cable and installed the lights and fans. I also drilled holes to run cable into the storage compartments. I installed cable glands in these holes with Sikaflex 221 sealant. The cable can be passed through the gland, Then the gland fitting is tightened and an inner grommet gets compressed, creating a seal around the cable. I tidied up the cables with some of the spare plastic track I was using on the ceiling and cut a strip off of an old yoga mat to put under the battery when I reinstalled it.
Alright, so I haven't changed anything about the cab. So we still have our old storage setup, homemade center console, and the storage area behind the driver's seat. It was a good system, it worked well for us, but now this is going to be where I put the water tank. So I'm going to pull this whole thing out and probably try to reuse some of the framing and stuff from this.
I cut down the steel frame from our old storage box to build a mount for our new 20-gallon fresh water tank. After a coat of Rust-Oleum rusty metal primer and stop rust enamel, it was ready to be installed. The tank mount is secured in place with 3 bolts that used to hold the rear seat in place, and the bolt that holds the driver's seatbelt to the floor of the cab. I covered the top of the mount in foam rubber tape to avoid wearing through the tank, which test fit nicely. But before I put the tank in permanently, I have a few more things to do in this corner of the cab. I built a wood mount for the water pump that simply wedges into this corner, and the pump is screwed down to the wood. Power for the pump comes from the house battery fuse block inside the camper. It runs through the camper floor, then through a wire gland in the back of the truck cab, where it is hooked up to a switch mounted on the water tank mount, and finally hooked up to the water pump. I installed the first couple of fittings on the bottom of the water tank, then installed it in the cab of the truck. I drilled a hole through the rear bumper and welded a mount on the underside so I could install a hose bib. Then I cut a hole through the camper floor and sealed it with Sikaflex 221 and a plastic through-hole fitting. This is to supply water to the sink that I installed in the passenger side cabinet. Once I cut the holes for the sink and faucet, I coated the exposed wood in epoxy resin and installed the faucet with its provided O-rings and the sink with siliconized acrylic latex around its mounting edge and around the drain fitting. The water coming out of the faucet will flow through 2 filters, first a 5 micron, then a 0.02 micron filter. This process will remove sediment, bacteria, cysts, and viruses, making clean drinking water. If I had more space, I could have just mounted the housings on cheap standard brackets, but I don't have the space to access the mounting screws once the filter is under the counter. So I made a bracket that I pre-installed on the filter housings, then mounted the entire unit to the wall under the counter with Sikaflex 221 and panhead screws. These various components of the system are plumbed together with braided PVC hose and barbed hose fittings. We got our sink and faucet installed, so you could hear the pump turn on and off as we turn the water on and off. From the sink, the water would run down through the drain hose and into our 5-gallon gray water tank. That way when we're doing the dishes, little food scraps and stuff all end up in the tank, and then we can shut off the valve and remove the drain hose, and then we'd be able to pick up the whole tank and walk it off away from camp and away from any other campers in order to dump it out. Now I am going to install a toilet, specifically the Nature's Head composting toilet. The package contained the toilet, vent hose, agitator handle, power cord, mounting hardware, and instructions. The first thing I did was attach the agitator handle, which only required tightening 1 bolt. Then I test fit the toilet. Alright, I got the toilet into the spot where I intend to mount it. And I knew it was going to be tight, but I think I'm actually a little too tight. So I got a little bit of figuring to do to try to make this all work in the space that I have for it. The first modification I made was to shorten the air intake fitting. So I trimmed it down with an angle grinder and cleaned it up with a file. Next, I used a bit of leverage to bend the trap door handle a little closer to the toilet bowl. I reattached the handle cover with some adhesive. The exhaust fitting also needed to be trimmed down, but I didn't want to get a bunch of plastic dust into the fan, so I disassembled it before trimming it off. There still wasn't enough room for the exhaust hose to come straight off the exhaust port, so I trimmed down a 90-degree PVC fitting that fits snugly onto the exhaust port. The toilet fit and operated correctly at this point, so I marked off where I wanted the mounting brackets and secured them to the floor with Sikaflex 221 sealant and the supplied hardware. When the toilet is in place, it will be secured to the mounting brackets with one thumb screw on each side. I ran the wire to power the exhaust fan. It runs off of 12-volt DC power and draws about 0.07 amps an hour. I cut the supplied power cord down a bit shorter, crimped on some ring terminals, and ran the wire underneath the counter to the passenger side fuse block. The exhaust hose still needed to exit the camper somewhere, so I cut a hole in the floor behind the toilet. I installed a through-hole fitting in the hole with a generous amount of Sikaflex 221 sealant. Finally, I cut down the vent hose to an appropriate length for my application and attached my PVC elbow. To prevent pinching or snagging the power cable, I mounted it to the wall with some leftover cable track. This also holds it in a convenient spot to grab the cable when plugging it in. This is the process I will do to reinstall the toilet each time I empty the solids bin, which should be about once every 3 weeks with 2 of us using it full time. It's a bit of a task, but not nearly as bad as hiking off and digging a hole every morning. And that's not always an option. Honestly, having a toilet would have been so handy during our Central America trip, it may be the upgrade that I'm most excited about. Now I am going to install drawers in the camper, starting with the space at the front of the camper underneath the bed. I am using scrap 3/8-inch plywood left over from when I built the countertops and Cabover. I cut the material to size and use exterior grade wood glue and finishing nails to hold the pieces together. I use scrap 5mm plywood to make the drawer bottoms and attach them with exterior grade wood glue and nails as well. The drawers are mounted in the camper with drawer slides through bolted to the drawers and to the camper walls. This process was repeated for each of the drawers in this area, with adjustments made to the dimensions of each drawer to use the space best without encroaching on the electrical system. Next, I wanted to have a couple of drawers under the sink. I ran out of scrap 3/8-inch plywood, so I grabbed a dresser I found dumped in a parking lot and reused the sides of the drawers to assemble boxes that fit my space. The sides are glued and screwed together, and they already have a groove cut into them that fit the 5mm plywood I was using as my drawer bottoms, so I just cut out the drawer bottom and glued it in place. I screwed the drawer slides onto the sides of the drawer and through bolted the drawer slides into the camper walls. To hold the drawers closed while driving, I modified some bolt latches and catches to fit in my tight space. When everything seemed to be working properly, I removed the drawers and coated them in a combination of leftover paint and polyurethane. Then I reassembled everything with Sikaflex 221 caulking anywhere the hardware entered wood. With the drawers finished up, I turned my attention to the stove. Our 2-burner propane stove is a bit tired looking, but the burners are still working well, so I cleaned it up and replaced the rusted apart hinges with some random hardware that I had kicking around the shop. I didn't want to have to set the stove up or store it away somewhere every time we broke camp, so I dismantled the stove and used some scrap aluminum to add tabs off either side of the stove. I then drilled a couple of holes through the driver's side countertop and used epoxy resin and fiberglass to seal the wood and to install T-nuts in each hole. I got a silicone mat to go underneath the stove to protect the countertop from wear or heat. The stove can now be secured to the countertop with a couple of thumb screws, and it can be easily removed if I want to cook outside or clean around the stove. At this point, I finally got around to coating the interior with polyurethane to provide some UV protection for the epoxy resin. I also made a little rack behind the stove for our 1-pound propane bottles out of some scrap plywood and 1x2 lumber, glued and screwed together. These little eye screws with some bungee cord run through them hold the bottles in place. And the rack is screwed to the wall with a little bit of Sikaflex 221 around the screw holes. I'm going to build an adjustable, removable surfboard rack in the driver's side storage compartment. I started by building the mount that the rack arms will attach to. I am using a piece of aluminum extrusion that was previously an ARB awning mount. I cut the material to length, cleaned up the ends, drilled out mounting holes, and cut holes for the mounting hardware to recess into. Then I dry fit the mounts in the camper before attaching them with Sikaflex 221 and through bolting them to the camper wall. Next, I used some bits of thin steel tubing and steel plate to build the rack arms. The tubing was cut to length and cleaned up so that I could weld it to the small pieces of steel plate that I cut out with an angle grinder. Each plate was given 4 mounting holes before getting welded onto the tubing. All of the rack arms were coated in Rust-Oleum rusty metal primer and enamel, then attached to the aluminum mount with 4 bolts each. The aluminum extrusion holds the bolt heads so that they can't spin while allowing them to slide vertically. This lets me add, remove, or adjust the height of the rack arms, then tighten the nuts to secure them in place. I used simple bungee cords to hold the surfboards onto the rack arms. I stripped the plastic off of one hook on each of the bungees and reshaped it to fit snugly around each rack arm. Then I tacked it in place so that it won't slide or come off the arm. Each arm is padded with self-adhesive nitrile foam tape. Unfortunately, the adhesive wasn't working great on the tight radius of the rack arms, so I secured it with hook and loop, aka Velcro, double-sided strap. I am quite happy with my results. The rack accommodates surfboards up to 6.5 feet long. I can fit up to 3 boards with each one having its own rack for easy access. Or I can remove the fins and adjust the rack arms to accommodate more boards or to accommodate other equipment like snowboards or fishing poles. Having the rack inside the storage compartment allows me to securely stow my equipment away from the hot sun, scraping branches, and sticky fingers, while not tracking sand or snow into our living space. This is definitely an upgrade from our previous setup. Next up on my to-do list is mounting and wiring a light bar. Auxbeam sent me this 42-inch LED light bar they call the 5D Pro. I decided to mount it in my front bumper to keep it as discreet as possible. So I removed the front bumper and used an angle grinder to cut out a hole in the bumper for the light to shine through. I made a couple of Z brackets by welding together some pieces of angle iron. These will give me an easy place to secure the adjustable mounting brackets that came with the light bar. I test fit the Z brackets with the light bar and the bumper in place, and when I was satisfied with the fitment, I welded the Z brackets onto the truck frame. I cleaned up the welds in the surrounding part of the truck frame and coated it in rusty metal primer and stop rust enamel. The bumper and grille were also painted black before I reassembled my front end. My front bumper was already dented, scratched, and rusting, so going into the project I wasn't really worried about making it look perfect. The black aluminum frame on the light bar goes nicely with the black bumper and grille, and I'm happy to finally get rid of all that shiny chrome on my front end. Wiring the light bar was super easy with the included wiring harness from Auxbeam. I mounted the rocker switch in my dash, ran the wires through my firewall to the battery, and plugged in the light bar at the other end. The most important thing, of course, is how it performs. The stock lights on this 29-year-old truck are pretty dim. Now this is with the stock brights turned on, and now with the light bar. We don't like to drive at night, but we do occasionally get into camp later than planned, or start driving before the sun rises. Having this powerful light bar from Auxbeam will help keep us safe on those occasions. Our entry door is pretty high off the ground, so I'm going to fabricate an entry step. It will swing down from under the camper, pivoting on these brackets I'm welding onto the spare tire carrier crossmember. I built the swing arms out of 1x2 inch steel tubing. I capped the ends with 1-inch flat bar and welded on tabs to attach the arms to the pivot points on the crossmember. These shorter sections are also 1x2 inch steel tubing, and I capped those ends with 1-inch flat bar as well, before grinding down my welds and attaching them to the larger swing arms with modified hinges. This should result in a level entry step if all my math is correct. The step itself is a piece of 6-inch by 1-inch C-channel. I cut a few holes down the center of the tread and used press sleeves and a hydraulic press to achieve a dimple die effect. The idea is that we will be able to wipe our feet off on the step more effectively and have the dirt or sand fall through the holes instead of accumulating on the step. I welded the step onto the swing arm assembly, and then welded these pieces of chain link onto the swing arms and onto the rear bumper mounts. The chain links are attachment points for these support lines. This is 8mm double braided Dyneema line. I shrink wrapped the ends and tied bowlines to attach stainless steel carabiners. The final piece of the puzzle was a couple of bolt latches, which I welded onto the swing arms. The entire assembly got coated in Rust-Oleum rusty metal primer and a tan spray paint. The swing arms are bolted onto the mounting brackets with a nylon washer between the arms and the bracket. The Dyneema support lines hold the step at the desired height, and shout out to Mrs. Wright, my high school geometry teacher, because the step ended up nice and level. Obviously, just buying a step stool would have been a lot easier, but they don't work on a lot of uneven terrain, and we don't camp on a lot of level paved surfaces. I think I'll get better with practice, but for now, it takes me about 40 seconds to deploy or stow the step. It's stable and sticks out far enough behind the rear bumper to feel comfortable getting in and out of the camper, so I'm calling it a success. Now I'm going to modify our ARB awning to fit onto the back of the camper. This is the ARB 2500 awning, which is roughly 8 by 8 feet. I am modifying it to be 6 by 8 feet. I removed the canvas from the assembly and cut off the excess material. I folded over the raw edge on itself twice and taped it in place. Then I proceeded to hand sew the 8-foot long hem with a slip stitch. Next, I shortened the aluminum extrusion that mounts the awning onto the camper and holds the awning arms. New mounting holes were drilled, and the awning arms and end caps were reinstalled. Next, I shortened the aluminum extrusion that attaches the canvas to the awning legs. I cut a small piece of the excess material to fabricate a bracket that allows the legs to fold into a stacked orientation so that both legs can fold up along the shortened extrusion. I shortened the awning bag and stitched it back together, and used Sikaflex 221 to attach the aluminum mount to the bag. Then I used 1-inch panhead screws and more Sikaflex to attach it to the camper. The canvas was reinstalled in the aluminum extrusions and secured with a screw in each corner. The modified awning deploys and stows in the same way as the original. It's easy to do with 2 people, but a bit cumbersome on my own. I will continue to carry stakes to guy out the awning as we did in the past, but I also added these eye bolts to the rear bumper to use as guy points for when the ground is either too hard or too soft for stakes.
Well, there you have it, the complete build process for my new Overland camping rig. If you have any questions, leave them in the comment section down below, and keep an eye out for my next video, where I'll answer the questions I get asked the most. Until next time, thanks for watching.